All right, students, friends, in this video I'll be talking about Newton's laws of motion, and the conclusion of this deliberation will be that we will realize that Newton's second law of motion is the real law of motion, because we can achieve both the results of the other two laws, Newton's first law of motion and Newton's third law of motion, from Newton's second law of motion. Now, if I quickly go back to the statements of Newton's laws of motions, then the very first law says that a body will stay in rest or in uniform motion unless and until a net external force acts on it. Now the point is net external force. That means if a body is in a state of rest and if you are applying certain forces on it and the result of these forces is zero, so that means if I have to talk about the first law, I'll say that if there is some body on which F1 is acting, F2 is acting, and F3 is acting, and the resultant of these forces is zero, in that case also the body will remain in the state of rest or in the state of uniform motion. Now, going to the second law of motion is that the net force acting on a body is rate of change of its linear momentum. So whenever there is a change in linear momentum with respect to the time, that means we should automatically understand that some net external force is acting on the body. And the third law, the statement of third law is quite evident. It's used in all phrases in daily lives, that for every action there is an equal and opposite reaction. That means whenever there is an action on somebody, that body will exert the same kind of reaction to the body which has exerted action on that. And obviously the direction of that reaction will be opposite to the direction of action. Now in this video what we are trying to do is that we are trying to realize that the core law out of all the three laws is the Newton's second law of motion. Now we can see that from the very first, if I write down here Newton's second law of motion, now Newton's second law of motion can be written as F is equal to ma. Now this F is the net force acting on that body, m is the mass of that body, a is the acceleration. Now if you have the net force that's being acted on some body, this body will have a uniform acceleration. Now if this a is 0, if there is no acceleration, right? Now how come we can reach to this conclusion that there is no acceleration? If there is no acceleration, I would say either the body is in a state of rest, or I will say this body can have a uniform velocity. So the case is quite simple. If I say that this F external, this net force acting on the body is 0, then automatically the result will come. This result will come, that the acceleration will be 0. So having 0 acceleration means dv by dt is equal to 0. So there is no change in velocity. That means both the conditions can be satisfied, that a body can stay in a state of rest, or it can have uniform motion. So that's a realization from here, that the first law is already contained in Newton's second law of motion. Now let us try to achieve third law from this Newton's second law of motion. For that, if I take a system like this is a body and there is another body on this. Okay, I will call this body 1 and I will call this body 2. Now this body will exert some force on this body, and this body will exert some force on this body. Now the force that 1 is exerting on 2, I will call that force as F12. And the body 2 that's exerting force on the body 1, I will call that force as F21. Now I can write down Newton's second law of motion for two bodies separately. Okay, for body 1, if I write down for body 1, okay, F12, okay, it must be, according to Newton's second law of motion, dp by dt. So I'll call it P1. Similarly, for body 2, what is the force? The Newtonian force is F21, and this is rate of change of momentum. So rate of change of momentum is dp2 divided by dt. Alright, so I have a system, an isolated system, in which two bodies are exerting force on each other, right? And the force exerted by 1 on 2 is F12, and the force exerted on 2 by virtue of 1 is F21. And then what I do, I do write the Newton's second law of motion for the force that is being exerted by body 1 on body 2, and for the force that is exerted by body 2 on body 1. Now what I will do, I will name this as equation 1, I will name this as equation 2. I will add the two equations. What will I get out of this? I will get F12 plus F21 is dp1 by dt plus dp2 by dt. These are the only two forces acting in the given system. There's no external force acting on this system. So if I write down it like this, that F21 plus F, okay, it should have been F12. F21 plus F12, it must be d by dt of momentum. Now the things are clear here, that the net external force acting on this system is 0. Net external force acting is 0. Now if this net external force acting on the system is 0, there should be the rate of change of momentum should be 0. There should be no change of momentum in the given problem. So equalizing this to 0, we will get Newton's third law of motion. So this whole thing must be equal to 0. What I will get F12 plus F21 is equal to 0. So F12 must be equal to minus times F21. So here the things are very much clear, that the force that's acting on 1 due to 2 is equal to the negative of the force that is acting on 2 with respect to 1. So from this result, it is evident that that Newton's third law is automatically the result of Newton's second law of motion. So the conclusion must be this, that Newton's second law is a real law for the given state of problems involving Newton's laws of motion in mechanics. So the other two laws can easily be evaluated, can easily be achieved by virtue of Newton's second law of motion. So we can say that Newton's second law is the real law of forces, it's the real law of motion.